Observing the Radcliffe Wave on episode 286 of the Actual Astronomy Podcast. I'm Chris, and joining me is Shane. We are amateur astronomers who love looking up at the night sky. And this episode is for anybody else who likes to look at the nighttime sky. And tonight we're going to talk about the objects you can see in a wave in space. So today on the show, we have a special guest, a returning guest actually, who has a PhD in laser spectroscopy. He writes about astronomy and stargazing on his cosmicpursuits.com and also writes for Canada's Sky News magazine, which is the astronomy magazine here in Canada. He's a contributing editor for Sky and Telescope magazine. We're in January. In the January edition, the latest article appears by Brian, which is titled Riding the Radcliffe Wave, Trace Objects Along This Newly Discovered Structure in the Milky Way. Welcome back to the show, Brian. Great to have you.
Thanks, Chris and Shane. Good to be here.
My apologies. We had some technical glitches here tonight, and I'm cobbling things together, very MacGyver-ish like.
Not uncommon in astronomy to have technical glitches, I'm sure. I'm sure people will relate.
Yeah.
Not at all. So
that's why my eyepiece case has duct tape and screwdrivers.
Exactly. So we had you on about 6 months ago. Actually, when this airs, it's going to be 6 months within a day of when you were last on the show. So thanks so much for coming on again.
Good to be here. Yes, I think it was episode 234, an easy one to remember.
Excellent.
Oh, yeah.
Yeah. And yesterday we did, I was seeing we did a marathon session, Shane and I did, that is, where we recorded 5 episodes. So I was saying this is very much like podcast dessert for us. So we're really excited for this episode.
I'll try to do all the work here. You guys must be tired. You guys must be tired.
We appreciate it. Yeah, and I think we're both working today too, so at our regular desk jobs. But before we get going talking about the Radcliffe Wave, just mention your website a little bit. cosmicpursuits.com. I'm familiar with it because sometimes when I'm doing my own web searches for the show or the other astronomy stuff that I do, I run across your website, and I'd remembered that there were some ebooks on there, and I was actually going to ask you to see if we could give away one of the ebooks, but then when I looked, the ebook that I'd wanted to give away is something that you're already giving away.
Yeah, that's right. I mean, so it's a Cosmic Pursuits is a site about people who want to explore the night sky, either as armchair astronomers or hopefully hands-on astronomers. But a lot of the people who come to it have different backgrounds. Some are, hardened amateur astronomers and experts. Others are just getting started. So I offered a series of ebooks just to get everyone oriented, so they can understand the articles once they start arriving in their inbox.
Yeah, that's the one, and sorry, I don't mean to cut you off, but the one that really caught my attention, and maybe you could speak to briefly, would be the Choosing Binoculars and Telescopes for Stargazing. That was a great ebook that I think a lot of listeners might be interested in downloading.
Yeah. So most people, when they think astronomy, they want telescopes. They want some hardware, some bling, right? But there's some things, as you know, that people should understand before they get a telescope or even binoculars. So this kind of goes through the very basics of what you should know before you even spend any money on optics, and then what you should look into when you're looking for binoculars, do's and don'ts, stay away from cheap optics, that sort of thing.
Yeah, exactly.
So it kind of just gets people up to speed.
Yeah, it's a nice section on the website. So when people go to cosmicpursuits.com, you've got a nice menu bar at the top. And then I think it's like a getting started, or no, it says start here.
Start here, yeah.
Very clear. People know where to start. And then you can go in there and you read into the first few paragraphs, and then you've got these books sort of appropriately linked. And they're all free for download, I think, if I recall.
Yeah, that's right.
Quite nice. Very cool. And what were some of the other ones that you have in there, just so people know?
There's one about what to see with your telescope and binoculars, so things to see in the night sky. And there's a third one. I think it was just a basic layout of the night sky. Again, it's just for any beginners who come across the site and want to read the articles. This helps them, just get the basics really fast. Nice. So these they can read through them, and there's also a free audio track if you want to hear the the
That's
sultry
right.
sound of my voice. I read through the books that people can put them on their iPad. So
That's
there's
awesome.
Stargazing 101, Night Sky for Beginners. Second ebook is What to See in the Night Sky. So moon, planets, but also deep sky objects, just so people know they can tell an open cluster from a globular cluster from a planetary nebula. And then the third book is the Choosing Binoculars and Telescopes for Stargazing. So a little triumvirate there.
Yeah, that's great. Good resources. We'll have to add that to our repeated list, Chris, of recommendations for people, maybe new to the hobby or maybe just getting back into the hobby.
And yeah, and I'm really glad Brian mentioned the audio files, because I had gone and looked and saw those, and I'm a little bit flustered tonight because I've been running around trying to juggle things here. But I did notice that, and what was neat about when I noticed it is I had been working on I've been attending a class because I'm working on building a new course at my job at the university, and as part of that class, they were discussing ways in which you can make your courses more consumable to different people. So, for example, some people may have challenges reading, or, for example, with our audience, they're an audience who enjoys listening versus maybe sitting down and reading something necessarily, especially where some people will even listen to stuff while they're on the way to go observing, or while traveling back and forth to work. Or maybe even at the telescope and such. So I thought, wow, that's really good, because I think it really handles the diversity of folks that we have who enjoy the program. So
yeah, absolutely. I love audio, even more than video, even. So I think a lot of people do. It's convenient.
Yeah.
So portable. Anywhere you are, you can be listening.
Yep.
It's sometimes hard to watch a video and drive. So.
Yeah, that's right.
Yeah.
I'm going to say this before we get going: is I have this is the latest edition of Sky News, which is a Canadian magazine, but I don't know. I should have looked this up, but I haven't been able to determine if it's available in the States or other countries as well, but maybe it is.
I don't know offhand. I don't know.
So I think people might be able to order it online, but because we're going to talk about maybe what might be qualified as a little bit more advanced topics tonight. And perhaps what I want to say first is that if you want some of other Brian's maybe more getting going information in the Sky News for January and February of 2023, there's an article in here called Sky Events of 2023, and you list the top 10 events. I'm not going to give a spoiler to any of those. And then as well, if you turn sort of just past, if there was a centerfold in this magazine, you would just pass the centerfold, and you have an exploring the night sky for the following 2 months there. And so if people find this conversation a bit on the advanced or esoteric side, then both Brian's website, Cosmic Pursuits, as well as the Sky News magazine for January and February would be a great place to get some more sort of novice level information. All right. Shall we dive into the Radcliffe Wave?
Let's jump in. Let's get our surfboards.
I think I've got to put water wings on. All right. So a few weeks ago, Brian, you and I were emailing a little bit, and you'd mentioned that your latest Sky and Telescope article, which was titled "Riding the Radcliffe Wave: Trace Targets Along This Newly Discovered Structure in the Milky Way," was out, and I was excited to read it. Because I'm always excited to read observing articles. But then as I was reading it, actually, I found it to be one of the better articles I've read in the past few years on visual observing, because you're really speaking to me in this, which is you're using your 85 millimeter refractor, a fistful of filters, and going out and observing some of these objects for yourself, and really tying it into some of the science behind how some of these objects are connected. And so that's just such a beautiful tie-in to many of the objects, which I've recently been, so it was right up my alley.
Yeah, there's a lot of stuff a lot of the objects that we're going to talk about tonight are well known, but what wasn't well known is how they were physically connected, which was kind of intriguing. And that's what I think that's what captured my attention when the Radcliffe Wave was discovered. It was announced in I think January 2020 by a group out of Harvard University and Radcliffe College, and they named it after the college. And it's actually a coherent, like physically connected, coherent set of gas clouds. It's not just a random set. They seem to actually be physically connected to each other and likely formed at the same time. They seem to be moving together through space. It's a wave that goes below the plane of the galaxy, through the plane of the galaxy, and above the plane of the galaxy. So it's like a damped sine wave, if you remember that from high school or university mathematics. Kind of a full, maybe 1.5 periods of a sine wave that's damped.
Okay.
And it was discovered by a pretty big group of researchers that were measuring the positions to dark clouds along the Milky Way. Well-known dark clouds from radio astronomers and so forth. And they used some data from the Gaia Space Telescope and some pretty cool statistical techniques that are way beyond me to sort out the distances to these clouds, which weren't well known before, and that found that all these things were connected.
Very cool. And in reading the article, in the opening, you reference Gould's belt, which I think many amateur astronomers are going to be familiar with, and that perhaps the Radcliffe Wave is a bit of a replacement, or am I wording that right? Of the Gould's belt?
Yeah, that's a good point. So the researchers knew what Gould's belt was, and just to recap Gould's belt, as I understand it, it was kind of noticed by John Herschel from South Africa in the 1800s, and then in the late 1800s by American astronomer. I can't remember his first name. Gould was his last name. And it's a ring around the sky that's tilted at an angle to the plane of the Milky Way.
Mm-hmm.
And you can notice this yourself. If you go out at night, you'll see Orion late in the year. A lot of bright stars there, and it's tilted. It's not on the Milky Way. On the other side of the sky, there's Scorpius, again, which is just off the plane of the Milky Way. And also kind of connecting those two through Taurus, for example, Cepheus, Cassiopeia, that sort of thing. And it was long thought that this ring was a physical structure, that it was formed maybe by a big clump of matter colliding with the Milky Way and triggering all this, the formation of these bright stars we see along this ring around the sky, the Gould belt. So along with bright stars, there's lots of dark clouds there too. So the researchers measured a lot of the clouds that they would find along the Gould belt. And with these highly precise measurements, they thought they would just map out the Gould belt in high resolution, essentially. But what they found instead was that there's really no physical belt. There's actually this wave, this Radcliffe Wave on one side of the sky, basically from Orion through Cygnus. And then on the other side of the sky, another structure called the split. So this is more near Scorpius and Centaurus. So these were kind of the two anchors of the Gould belt. But what they found is that there are actually two different physical structures that just happen to, well, I mean, any 2 points you can draw a ring through. So the Gould belt was actually an artificial construction through these two physically coherent structures. So it's kind of a projection effect along the sky. So essentially, unfortunately, they declared the Gould belt dead as a physical entity, and in its place we've got the Radcliffe Wave on one end and the split on the other end.
Okay.
Yeah, very interesting.
Very cool. So I noticed that, and one of the neat things I thought about in the article is that you detail the targets from Cygnus through to Canis Major. So it's this very broad piece of sky, and this is kind of the sky that we see now. If we went outside right now, and it's extremely cloudy here, it's warm for a change, but it's cloudy, and you look towards the west, high in the west sky right now, we have the summer triangle, and sort of right at the top of that is Cygnus right now. And that's sort of like, in a way, like would be the starting point. And then you could sort of observe throughout the night, and maybe sort of in a way you could have your own bit of a Radcliffe Wave marathon and observe your way up and through Cygnus and down into Canis Major, which is not nice and high until about 3 a.m. These days.
Yeah, that's right. That's right. This is the time of year, kind of November, December, January, where you can see the entire length of the Radcliffe Wave. So it starts kind of at the heart of Cygnus, which is this time of year, low in the northwest, from the northern hemisphere anyway. And you could follow it all the way across to Orion and Canis Major rising in the southeast. So yeah, it is just like a Messier marathon you can do in the spring. I guess you can do a Radcliffe Wave marathon this time of year.
I think it would take some work. I think it would take some work. I know I was recently working on some of these. I don't know if I'll get that or not. And I know there was one object I spent 90 minutes observing to get a decent observation of. So some of the objects here are fairly difficult.
Mm-hmm.
Some of them are. In fact, the original study of the Radcliffe Wave was a precise measurements to dark clouds, which are basically black as coal.
Yeah.
Not very interesting to visual observers, as I mentioned in the article.
Yeah.
But I spoke with one of the researchers, one of the lead authors of the paper, Joao Alves at the University of Vienna. Mm-hmm. And he's not only a professional astronomer, but also an amateur astronomer. He loves this stuff and knows the sky quite well. So we built up a list of dark nebula that can be seen or imaged, but also bright nebula that are associated with them, that go from these points in Cygnus all the way to Orion. And a lot of them are favorites. Some of them are not along the wave. So there's other foreground and background objects, like the California Nebula doesn't make the cut. Yeah. IC 1396 and Cepheus, a very nice nebula where the elephant trunk is. Yeah. Again, it's not quite along the wave. There's a big dust cloud there, but the precise measurements from this study, which was published in Nature, show that it's just in front of or behind the wave, a lot of these clouds.
Yeah. And it's neat because many of the topics, and one of the things that we focus on in our podcast, are what you can see visually. And so many times the astrophysics articles are more along that theoretical bend. So I really like the fact that here is some relatively recent information, being only 2 to 3 years old. And then, you've done the hard work here of kind of threading together that line between what the science is telling us now and what we can actually see through our telescopes. So I really appreciate that as an observer. I think it's a really well-written piece. And I think you've kind of hit on something that will appeal to many people who like to sort of push the limits a little bit.
Yeah, it's kind of fun to observe this way. You'll see on cloudy nights, some of the more advanced observers see it this way. Instead of seeing the sky as just a random collection of fairly beautiful objects, there's actually some science and some physics behind the structure of the Milky Way that explain why we see things in certain parts of the sky and how they're related to each other. So that's kind of a fun way to observe, to understand why the sky is laid out as it is, not just kind of knocking objects off a list to observe. Yeah. Although that can be fun too.
There's a bit of a narrative there, right? Like there's a bit of a story, and it's really cool that you've tracked that down for us. One of the things I was going to ask about is some of those clouds are pretty old. I was surprised when I read in the article, 50 to 30 million years old. Some of these clouds are. That's fantastic.
Yeah. I mean, it's not super old, I guess, in galactic terms. That was always kind of the age of the Gould Belt too. Mm-hmm. It's a fairly recent construction. So any stars we see along here, any bright stars, are likely no more than 30 million years old, and the clouds might be a bit older. And again, the stars are forming out of the clouds and still are. most of the Radcliffe Wave is just dark soot. So there's going to be in the next 10 or 20 million years a lot of new nebula and star clusters forming here.
Stay tuned. Very cool. Very cool. So maybe we should start talking about what some of these targets can be. Can you talk a little bit about some of the star factories in Cygnus? And maybe we could start, where does the Radcliffe Wave begin or terminate in Cygnus? And what can you see in and around Cygnus that is part of the Radcliffe Wave?
Okay. Yeah. In the article, there's a little diagram that shows the wave and how it goes up and down around the galactic plane. So just briefly, one end of it is in Cygnus, and that end of the wave is about 5,000 light years from us. Then as we get through Cepheus and so forth, it gets a little closer. By the time we get to Taurus, we're kind of staring the wave in the face. It's about 450 light years away, the dark clouds in Taurus. And then again, as we move towards Orion and into Canis Major, it gets more distant still. Again, it's about 5,000 light years away on the other side. In Cygnus, at the beginning, the wave actually starts at something called the Cygnus X cloud, or the Cygnus X star factory, which is a huge region of stellar associations and molecular clouds kind of right in the heart of Cygnus, kind of between Gamma Cygni and Albireo. But we can't see it. It's obscured by a lot of intervening gas and dust because it's so far away. Mm-hmm. So we get our first, if you're an imager, the first thing you'd see at that end of the Radcliffe Wave is the Snow Angel Nebula, or Sharpless 106, which is about 3,500 light years away. It's a tiny emission nebula, quite beautiful. I mean, the images from the Hubble Space Telescope are great. You can certainly image it. It's a small object. But the first visual glimpse, and this is primarily an article in Sky and Telescope for visual observers, the first visual glimpse is the North American Nebula, just around Deneb. So everybody knows that. North American Pelican. It's separated by dark nebula. There's dark nebula in front and behind. But this is the first view we get of the Radcliffe Wave. And there's a young star that's just formed out of the gas and dust around here that illuminates those two nebula.
Oh, okay.
So we're just getting a taste of it there. But that's both photogenic and also something you can see with your unaided eye in perfect sky. Or it's an easy object to image, and it's a great object to see with binoculars or a wide field telescope.
I have to say something though, because I know what some of our listeners are like, because we communicate with them quite a bit, and we have many people out there with 20-inch and larger Dobsonians, and I can just see a few of them saying, "I'm going to see that SH2-106 Snow Angel. I'm going to see that visually."
It can be done. I've never seen it myself, and 20 inches might be getting you in the range there. It would be very curious to see if anyone could see that visually. Yeah.
I looked it up, and I couldn't, not quickly anyway. I couldn't find any visual observations, and certainly with the equipment I have, it's beyond my scope.
Yeah. Sure. Yeah, I've got a snapshot of it, I think through a Celestron 6 and a small camera, just to see if I could find it. It was just tiny.
Yeah. Okay. Yeah. So it's one of those objects. So I was interested in sort of moving up and to the left or to the north, sort of to the north west-ish or northeast-ish direction, going up to the Cocoon Nebula. I really enjoyed your observation of the Cocoon, where you had your 12 by 36. I'm guessing those are the Canon image stabilized binoculars out. Take a look at that region.
Yeah. I mean, that's a nice area there for sure. There's a couple other big dark clouds in Cygnus, Legendre T3, for example, which is near the North American Nebula and the Northern Coalsack. But the next light we see along the Radcliffe Wave is the Cocoon. So that's IC 5146.
Yeah,
and that was explicitly listed in the paper on the list of dark clouds that they measured. So they measured to the dark nebula, but the Cocoon, of course, is an emission nebula and a reflection nebula and a dark nebula altogether. So it's just a lovely object, especially for imagers. But yeah, in dark sky, you can spot it in binoculars. Certainly the dark cloud, because it just looks like an absence of stars. And there's an embedded star cluster too. I forgot about that. Colander 470.
470,
yeah. Yeah. It's a very nice part of the sky.
Yeah, I was really excited to read it because, and I put in this is a very crude sketch because I'm just starting the white on black technique in
Yeah, that was really nice work. Yeah.
That was my first sketch that I did, and it was at about like 3 or 4 o'clock in the morning. So it's a little rougher. Things have improved since, but that
wasn't dark on white and then inverted in Photoshop. It was sketched that way.
That's the way it was sketched. I guarantee you.
Yeah, very nice, very nice.
A little bit, always fun to challenge yourself, and I enjoyed it because you were talking about going out with your 12 by 36s and taking a look for B168, which is this beautiful. I find that the dark lane visually through binoculars has more of like a straight line appearance than the meandering appearance it seems to have like in photographs or on star charts myself.
Pretty much. Yeah. But it's about 2 degrees long, so you do need some field of view there for sure.
Yeah, exactly. And I just really enjoyed the fact that you were out with your binoculars, and then I had been out with my binoculars, and then you were using your UHC in your 85 millimeter telescope, and I had my 100 millimeter telescope. It was very similar instruments, and so it was. I really felt like I was kind of beside you when you were writing about that and making these observations.
Yeah. The key thing is dark sky, but you can see these things with very modest optics.
And it's just a beautiful part of the sky too. There's so much to see. It's ideal for binoculars, and in my mind too. It's just a wonderful way to spend a couple of hours observing is right in that area.
Yeah, there's tons of stuff here. There's a lot of star clusters too, lesser known ones, but it turns out these are not physically connected to the wave. They're just too old. So again, as we follow this part of the sky, we're looking for the physically connected structures are essentially emission nebula or dark nebula. But it is a great part of the sky for sure.
So how dark a sky were you getting under? So for me, I was under, I guess, like a Bortle 3.5 or so sky, viewing some of these same things. And it was really cool because I think out of your list, I think I had observed like something about a third of the list, and I had sketched about, I don't know, probably 5 or 6 of these objects this fall. So
yeah. A lot of them are pretty bright, and I would normally go just west of Calgary into Kananaskis country, they call it. So as I look west there towards Cygnus, it's probably Bortle 3 or Bortle 2. I don't spend too much time with the particulars there, but it's pretty dark. Yeah.
Nice. Yeah, it needs to be a reasonably dark sky to start seeing some of this stuff. So I was also interested. You included one of my favorite objects in the list there, which is the Index Catalog, or the IC353 in the Taurus molecular cloud. And you described observing those dark lanes kind of like as fingers. I like that observation.
Yeah, I've just barely seen that visually. It's a beautiful object to image. But this is the closest part of the wave. So as I mentioned before, it's about 450 light years distance, so 10 times closer than what we were seeing in Cygnus. So this is a complex, I guess it's hard to see the shape of it. I mean, it really is finger-like.
Yeah.
It spans, it's about 20 degrees wide, and it's kind of 10 degrees northeast of a line between the Pleiades and Hyades.
Yep.
If you like. And so, I could see them with some of those constellation binoculars, that 2.1 power by 42 millimeter.
Without a filter, Brian?
Without a filter. Yeah.
Awesome.
You could just barely see the absence of stars. And so, on that same night, I grabbed a camera and I thought, am I really seeing what I'm seeing? And just, did a quick shot with a mirrorless camera to see if I was looking in the right part of the sky, and sure enough, that's it. So it is possible. This is not an easy object to see, the Taurus molecular cloud, but it's well worth it for sure.
It's a really interesting approach too. I've never thought of, taking the camera out to validate some of these challenging observations, to, just do a bit of a longer exposure to see if if you are kind of in the right area. That's a great idea. I like it.
Yeah, it's kind of stargazing with the DSLR. It's amazing what you can pull out in just 20 seconds at good ISO. These cameras are quite something.
Yeah, no kidding. That's awesome.
Cool. Let's see. Yeah, and so that's just sort of east of the Pleiades. And the question I had was about the Messier 45, because Messier 45 is a star cluster, and it's passing through a nebula, and of course that nebula is reflecting some of the light, and it shows up as sort of a blue gossamer glow around the M45 Star Cloud. But those aren't related. So I was wondering, and I like don't want to put you on the spot or anything, Brian, but I was wondering if maybe that M45 Star Cloud, or the cloud that's around M45, if that was part of the Radcliffe Wave or not, or whether or not you knew that off the top of your head.
So that's a super good question. So the way the wave was discovered is that they knew where these dark clouds were, and they just measured the distances to stars along the line of sight to pinpoint the distances to these waves. Mm-hmm. So they looked in very specific directions, and one of the directions they did not look in, as far as I know, is towards the Pleiades.
Oh, okay. So
the Pleiades is too old itself to be part of the wave, but it is about the right distance.
Okay.
So I certainly can't say for sure that dust cloud that the Pleiades is moving through is not part of the wave, but it wasn't part of the specifically part of the study, so I can't say that it is either. But that's a very interesting question.
And so now I'm curious. I don't mean to put you on the spot or anything, but it's like my own curiosity kind of peeking out here, because you've been chatting with the folks that are doing the astrophysical research. And do you know if they plan, and it sounds like they published this back in 2020 and you've been chatting to them since, but do they plan on doing like any more further investigation to see, which objects and maybe even discover some new objects that might have been unknown before this time?
Yeah, the work continues for sure. I think what they're most interested in is to see the kinematics of the wave, so how it's moving through the Milky Way, both away from us and laterally, but more specifically how it's moving with respect to itself. So is it oscillating like a wave above and below the plane of the Milky Way? And it seems like the answer is yes. But they're doing a lot more studies, again, with data from the Gaia Space Telescope, which gives very precise directions to stars in front of and behind the molecular clouds. Okay. So, yeah, there's tons of work going on. There's a lot of papers on the Radcliffe Wave if you want to search on archive.org or something like that.
Yeah, I took a look, and I just took the briefest of look at the original article just to kind of see, but as much fun as it is to read academic papers, which I spend some part of my days doing, I gotta say, when I'm relaxing, I just want to sit down with Sky and Telescope and have somebody do the hard work for me. So I really appreciate it. Good stuff.
Yeah. Even the astronomy articles at Astrophysical Journal or Nature or Science can be a little terrifying, but.
Yeah, I'm working on getting publications up online after Christmas, so I know what it's like. I work on the other end of the business, and when I relax and just want to do some astronomy, I want to leave my work behind me. Good stuff. You mentioned Orion and Canis Major are some of the brightest parts of the wave, and I just wonder, kind of maybe a little bit more specifically, what targets, what regions in Orion and Canis Major might be some of the best associations for people to try to target?
Well, again, I think the big names here. So the Orion Nebula, which is kind of the jewel of the old Gould Belt, is also the jewel of the Radcliffe Wave. So this is probably the brightest star-forming region along the Radcliffe Wave. And again, there's tons of dark dust here and so forth towards Orion. But we're seeing little blisters here of initial star formation along the Radcliffe Wave. So the Orion Nebula is the brightest by far. Mm-hmm. If you look towards the Flame Nebula, for example, which is adjacent to the Horsehead. All that complex is also very likely part of the Radcliffe Wave. So again, well-known objects.
Yeah.
The flame is easy to see visually.
Yeah.
The Horsehead, not so much.
Yeah, because the flame, that's NGC 2023, I think, or the Tank Truck Nebula, the Christmas Tree Nebula, sometimes people call it.
23 or 24, I can't remember. Yeah.
And then that one I've seen in binoculars just in my 7x50s from just a reasonably dark site out at the Moncton location there when I used to observe in Ontario.
Yeah. And then a lot of the other nebulosity there you see. So there's fainter nebulosity, the Barnard's Loop, for example, which loops around above Orion's belt and then east of the Orion Nebula and then back down towards Rigel.
Mm-hmm.
Very hard to see visually, very easy to image. Mm-hmm. So it's likely another assembly along the Radcliffe Wave. And then I've never been able to see this myself, but the Lambda Orionis Nebula, which is kind of at the head of Orion, it's about, 5 or 6 degrees wide. Very nice star cluster there, Colander 69, I think. The nebula itself is great to image, but I've never seen it visually. But it is probably associated with the Radcliffe Wave also. You've seen this, Chris, I think?
Yeah, I've seen it. I'm going to just skip back to the Barnard's Loop for a second because I'm with you on that. It can be really difficult to observe, but thanks to Shane, I've made so many observations of it actually, because I should have brought it up here. He made me this tiny little telescope Shane has his there. Yeah, he can just reach back and grab it probably. Because he made one for himself. He kept the good one, and then I got his broken parts. Yeah, there we go. So we each have one of these. Now, this looks like a finder scope, but rest assured, this is like just about $1,000 instrument. And the magic to these telescopes is you can put in a 2-inch diagonal and a 2-inch wide field eyepiece. And of course, then you can use your 2-inch H beta filter. And with that, you can actually just sort of sweep through that whole area. And Barnard's Loop is not easy to see, but I would say it's pretty easy to see. Like it's probably about as easy as seeing, I would say like the Eagle Nebula through like an 80 millimeter telescope, for example. Okay. When you use this type of configuration, yeah, it's interesting, but you can actually see. I can get about 10 degrees field of view with that telescope. And so it actually encompasses the majority of at least the brighter section of the Barnard's Loop there.
So 50 millimeters, what's the focal ratio on that little instrument?
What are they at?
It's a speedy F5.
F5, okay. Yeah, that'll help.
Yeah, and so then we use these sort of wide, I have a bunch of these inexpensive like 30 millimeter and then more expensive like 32 millimeter Japanese eyepieces that are pretty lightweight. So I think it's not a great combination with like the Nagler 31. But what are you using for a really low power wide field eyepiece, Brian?
Depends what I'm using. If I'm using the binocular telescope, the 100 millimeter binoculars, I usually use a set of 24 millimeter panoptics.
Okay.
And in the Teleview 85, I'll use the same eyepiece, or if it's a bigger object and it's dark sky, I'll use a 35 millimeter panoptic, so a big 2-inch eyepiece.
Okay.
Which I think gives 4 degrees in that telescope.
Mm-hmm.
But
nice.
The 35 pan is a great eyepiece. It's a nice blend of wide field and not too heavy of an eyepiece. I really like that one.
Yeah, it's really nice. It's got a long eye relief. It's kind of hard to position your eye just right, but it's worth the effort for sure.
When I had it, I had that same issue, and I bought the Teleview eye cup extender, and that helped me a ton. It made it so much easier. Yeah, big help for sure.
Nice.
So I might, now that you've inspired me now to try the Lambda Orionis Nebula, because I've never seen it visually. Maybe I'll give that a go with the Teleview 85, or maybe even in the binoculars.
Oh, I even put notes. I think I sent you that image. I even put notes on my image for a change, and I was using that's with my 100 millimeter and an H beta filter, and I observed that just on October 7th. just
for Lambda Orionis.
Yeah, for Lambda Orionis. So, but I don't know what power. I think I was probably using either my 32 mil or my 40 millimeter. So it's given somewhere between like 18 and 25 power, but it showed up quite well. I'm going to say not as easy as the Horsehead, or sorry, not as easy as Barnard's Loop. Definitely not as difficult as the Horsehead.
Okay, yeah, H beta. Yeah, I don't have one of those. Maybe Santa Claus will bring me one.
And if Santa Claus doesn't, I have a lot of filters. I have a bit of a problem. Some people have a what do they call it, FOMO, or fear of missing out. I have a fear of missing filters. But one of my filters is in Calgary right now.
Oh,
and so if he was so kind, our listener Eric, I'm sure would be happy to share with you my 2-inch H beta filter. If you're making some observations, it is over there somewhere. I'm sure we can connect you with it.
Okay. Okay, sounds good.
So just let me know. We can arrange that pretty easily, I think. So yeah, he's in Calgary as well. All right. So seeing the Lambda Orionis, I think, that one is really nice. Some people have claimed to see it naked eye just with the H beta. I haven't been that lucky, but I think with the H beta on the 85 millimeter, that should be a really nice sight, actually.
Okay. It's on the list for the winter then.
Yeah, I haven't had any luck seeing the Horsehead in the past 2 years. Not sure if you've been able to track that one down, but I've been out of luck.
I've never seen it. I could ask both of you since you're right here. What's the smallest aperture you've ever used to see the Horsehead?
I haven't actually seen that one yet. My winter observing under dark skies, like we were chatting before we pressed record, Brian, I don't get out to too many dark skies in the wintertime, and that's high on my list. If I do get out, hopefully this winter under dark sky, I'll certainly give it a go. But Chris, I know you've seen it a few times.
Yeah, I've seen it about 5 times. I've hunted it down successfully 3 times myself. And in my 5-inch apochromat, using the filter that's in Calgary and my 40 millimeter Pentax XW, which is about 19 power, I'm able to get it. The big thing with the Horsehead is you want to see that nebula. What is it? IC434. You want to see IC434, and then just forget any image that you've ever seen from like a deep sky photograph or a CCD image. Just take the black pen from the Men in Black and just wipe that from your mind. And what you're going to see is you're just going to see kind of like a bit of a divot or a deviation in IC434, which is the nebula that the Horsehead is superimposed in front of. And that seems to be kind of the trick. There's a star just opposite. I think there's a nebula over there, which is like, I'm going to say it's like NGC 2095 or something like that. But anyway, it's sort of like this whitish nebula. And on the nights that I've seen it, I've tracked that nebula down first, whatever nebula is opposite that. And then I've been able to see the Horsehead. And then I've seen it through some bigger instruments. But I got to admit, even in like 12 or 16-inch instruments, it wasn't that much more visible. It was just like the image scale was larger. But I always think it's kind of unfortunate that the Horsehead is probably the most famous dark nebula because
yes.
It's like probably the hardest one to see, right?
Yeah, wouldn't that be something? It's very easy to image. It doesn't take much to have that pop out on a camera, but yeah, visual, it's a very, very tricky thing.
Yeah. Speaking of tricky ones, have you and this one probably dogged me for longer than anything else, is to see the Witchhead Nebula.
Yeah, I'm pretty sure I've seen that. I claim so in the article. Again, this was from west of Calgary here on a super clear night, but it's extremely hard to see. So this blob of gas, IC 2118.
Yeah.
This was explicitly listed in the original paper, and at least in the data they used for the original paper in Nature.
Mm-hmm.
So this is definitely along the Radcliffe Wave. It's a reflection nebula, just a few degrees west of Rigel.
Yep.
And it's about 3 degrees long, I think, 1 degree wide. And it, again, great. Well, actually, it's even hard to image, to be honest. You can't really use a filter because it's a reflection nebula, so you can't use a narrow band filter.
Yeah.
But I think I've seen the brightest part of it.
Yep.
With the 85, just a little smudge about a degree or so south or southwest of Beta Eridani.
Yeah.
In Eridanus. So certainly not the full view of the Witch's Head, but just the brightest part of it. I mean, I thought, maybe it's frost on the eyepiece, but I tapped the telescope and warmed up the eyepiece and looked again. I was pretty sure it was there, and it was quite rewarding to see that visually.
Yeah. When was it you observed that?
That was let's see, just after I moved here. So that must have been like early 2019.
Oh, okay. Yeah, that one dogged me for so long, and I kind of thought I saw it one night, but it was really like ethereal. Like I never really felt like I had it nailed. There was one night I thought I saw it, a couple nights I thought I saw hints of it, and then this autumn I had a really, really good night, and I got up, and what time did I sketched it at I didn't even put the time in, but I'm pretty sure it was like 3 a.m. and I spent I think the better part of an hour and a half getting it nailed down and actually getting a sketch off. But I didn't really look at any charts or anything. I just went out because I'm so familiar with the field because I failed so many times that I kind of know where it is generally. And so I just drew in the brightening in the 4-inch. And then I was like, I don't know if this is it. And then when I went in and I looked at the software and I went back and forth, I'm like, yeah, I got the right brightening in the right spots. But I was pretty doubtful until I did that. So
yeah, it takes some time to be sure, for sure. I'd love to see it again.
Yeah, the other objects that are on there that are on the top of my observing list to do are the Seagull Nebula. I failed at seeing that one quite a few times as well. That's right up at the top of my list.
Yeah, it's not much to look at visually, but it's a nice little object. And this is towards the end of the wave. So again, we're down in Canis Major and Monoceros and that part of the sky, about 5,000 light years away. So the Seagull Nebula is IC 2177.
Yeah.
It's stuck in a big cloud of dust called the Canis Major OB1 cloud. So there's a stellar association and a lingering cloud there that was part of the study. But I saw it in a 10-inch Dobsonian. It wasn't much to see. There's a lot more accessible with the camera, but it's a nice little object to see it. And what else?
It's pretty big, isn't it? Isn't the Seagull a fierce?
Yeah. It's bigger than the full moon.
Oh wow, huge.
Oh no, sorry, that's not right. The full moon's 30 arc minutes. It's about 20 arc minutes around.
Okay.
The part that I saw. Yeah.
Okay. Like kind of like the bright. It has like a bright core, I think, or something.
Yeah, I didn't see much of a shape. I just saw kind of a linear nebulosity.
Yeah.
Whereas the imagers can pull out that nice seagull shape.
Yeah. Yeah, I'm eager to see that one. The other one you had on there, and I had this on my list to observe this year, and I have no excuse. I don't know why I didn't get this one, was the Iris Nebula. I keep meaning to, I think I've seen it before, but I wanted to sketch it, but I didn't get it.
Yeah, that's a nice one. I can't pound the table and say that's definitely part of the wave, but it very likely is, just from the age of the star and the nature of the nebula itself. So it's a star that's surrounded by a cloud of dust that it's lighting up, and also some dark nebulosity, and the distance to it is just right. I don't think that particular nebula was part of the study, but just the age of the star and the distance to it means it's probably along that wave.
Yeah.
And so that's in Cepheus. I don't know how many imagers listen to this podcast, but in that part of the sky, there's some really photogenic dark nebula that are certainly along the Radcliffe Wave. So that's LDN 988.
Okay.
LDN 1251.
Okay.
1265 and LDN 1333, all in Cepheus or Cassiopeia, I can't remember, but they're all up in that part of the sky. They kind of mark the part of the Radcliffe Wave that extends the furthest above the plane of the Milky Way. All very photogenic, but they're for serious imagers. You see these beautiful images of these dark nebula with lighter regions around it. It looks like big smoke puffs along the Milky Way.
Yeah.
That's what these objects are.
Yeah. No, it's very neat. Yeah. The iris was on the front of the RASC Observer's calendar this year. And I knew I had a preview, of course, because I'm the editor for the calendar. So I had wanted to see it. And then I don't know why, but I ended up sketching the California Nebula 3 weeks ago. But then it turns out that's not even on this list, unfortunately.
No, it's close to the way, but not quite on there. Yeah, that was the first thing I asked Catherine Zucker, who I think was the leader, the second author on this. She said, no, it doesn't quite fit.
Darn.
Yeah.
That's beautiful. And I always, when people are asking me, because I'm a really big H beta observing fan. That's one of my
apparently.
Yeah, well, I've been doing it for like 20 years, trying to observe all the H beta objects, and now I think I've observed all the ones that you can see with a small scope. Now I'm going through and trying to sketch them all. So when people are asking what to start with, I'm like, start with the California Nebula, because you can even see that in binoculars without any filter at all. It's that bright, and then you can kind of start there and maybe go up to the Flame Nebula and then work through some of the other bright ones.
Well, I think if you haven't done it already, that would be a great topic for a podcast, because I keep looking at H beta filters and think, wow, what can I see with that? Like maybe the Horsehead, maybe the California. That's about it.
Oh yeah.
So
well,
if there's more, I would love to be educated for sure.
Yeah. Well, the big one there around Lambda Orionis is one that responds well to that. And then there's some other. I like the Cocoon. I like that one in H beta as well. UHC H beta works well. So I should have brought it up, but I've got a big. It looks like some sort of monstrosity of a diagonal for a refractor, but it actually has a big filter slide on it. And then what I can do is I can load up. I have a Teleview H beta. It's called a Nebustar, but I like to say it's a neb buster because it really busts those nebulas. And then we've got the Lumicon 03 and Lumicon UH3, both Gen 3s. And then I keep an open slot. So then what I can do is I can be viewing without a filter at all, and then I can slide back and forth to see which one is going to give the best views.
Oh, nice.
It's a neat setup, but they don't work too well on the reflection nebulas, of course. Working on something to reveal those a little more. And one of them is, and this there's a few objects here that have really dogged me, and I failed to see. Seagull being one of them. The other one was the IC348 Nebula. You mentioned there is a cluster there, but that one I have failed to see on so many occasions. That is a tough one to see too.
That is a hard one. Yeah. I've seen. It looks to me just like maybe a fuzzy star. It's pretty small.
Yeah.
So it would definitely profit from some aperture. I could just barely see it with a 10-inch.
Oh, really?
Yeah.
Oh, wow.
Oh, okay.
Not the star, but the nebulosity.
The nebula. Yeah. Oh, okay. Yeah. Even in my 5-inch, I've never been definitively able to say that I saw it. So, yeah, I'm working on getting some bigger aperture at some point in time. So that's definitely one. That's actually good. I don't mind hearing that someone has seen it but it took them a 10-inch. And I'm like, okay, then just the 5 inches are they just might not have the light grasp and resolution to pull in that.
Yeah.
Cool. Let's see. That's kind of like our list of objects there. But do you want to just chat about the gear a little bit, Shane? Maybe about the Teleview 85 and that kind of stuff.
Sure.
Yeah, that kind of aperture, 85 to 100. It is a sweet spot for a lot of objects like this.
Mm-hmm. Mm-hmm. You know, I'm always astonished. Like, I've said it a few times on the podcast before that my first refractor was an 80 millimeter refractor, but I had that alongside a 12-inch light bridge, and I never really gave the 80 millimeter any thought as a serious telescope. I always thought it's way too small. Why would I ever use that little telescope when I have a big 12-inch Dobsonian beside me? And the more and more I started to use it, and even now with my 76 millimeter refractor, it still astonishes me just how much a 3-inch will show you, and that it's not always that far off from, say, a 4-inch or 5-inch, depending on the objects that you're observing. you know, if I could have one telescope, it might just be about a 80 millimeter refractor because of how portable and easy to use and wide field and capable for just about any object out there. So I just love that class of refractor.
Yeah, the wide field is nice. That's what keeps me using small refractors. You can almost see the way astronomers bifurcate, visual observers. Like, I guess like you, I had the first time I got an apochromatic refractor, I thought, wow, this is really nice. I think it was a 66 millimeter. I still have it. So I just keep buying better and better refractors, roughly of that aperture, kind of between 70 and 100 millimeters. The other team of visual observers just gets bigger and bigger and better. Dobsonians. They go for the aperture rather than the wide field. I guess both would be ideal, but
yeah, they both have their purpose, that's for sure.
Yeah. You guys, I follow your podcast regularly. You see tons of stuff. You've both got 100 millimeter Takahashis. Is that what you use mostly these days, or?
Yeah, for me, that's my primary telescope now, the TSA 102 triplet, my first triplet that I've ever owned, and I love it. It's a wonderful telescope. I was able to split Antares with it. When was that? Kind of early summer, late spring. And it's been a wonderful telescope. I really enjoy it. And, I've looked through Chris's 100 quite a bit, and it's, you're splitting hairs between them. They're pretty much equal telescopes. And, that 4-inch class again is just a super versatile telescope. Really enjoy it.
Yeah. It's the perfect kind of instrument for following the structure of the Milky Way. And, again, the Radcliffe Wave is just one of the many structures along the Milky Way, that we can follow. It's just when you look at the sky holistically like this, like these structures, it's much more interesting than just knocking things off your, Herschel 400 list or something. Although that's got its place for sure. But you start to see the sky in the Milky Way in 3 dimensions. It's quite interesting.
Well, yeah, when you think of all of this as a system, or like you mentioned at the start, physically connected. It sort of changes the perspective on some of these objects. And I think that's one of the reasons why I really enjoyed this article a lot. The other one too is as Chris mentioned, it just felt like I was observing with you and, reading about observing this stuff with an 85 millimeter telescope, or some of this stuff with an 85 millimeter, was quite fascinating. It definitely gave me sort of a new observing program, I guess, for this time of the year, as Chris mentioned, to do the Radcliffe marathon, so to speak. Yeah. So I think that's a great idea.
Absolutely. Yeah. If Sky and Telescope wants me to do fainter and fuzzier things, they can buy me a big Dob.
Seems like a good trade-off.
Otherwise, I'll work with what I've got. I know they've got some really serious big telescope deep sky observers who write for them. They do great stuff, but yeah.
Yeah, I went to Howard Banich's talk. I think it was 2 or 3 weeks ago. And he uses a 28-inch, and amazing stuff. But for me, it's like, okay, like that's cool, but I don't have a 20. I'm never going to own a 28. It's just
I love to read those articles, but it's just beyond me. It's like reading someone, going up Mount Everest. It sounds great. I'm never going to do it, but boy, it's really exciting.
Yeah, no, it is really cool. So I do have a follow-up question, kind of based on some of the stuff that you said there just now, as well as at the beginning, and that is that with the Radcliffe Wave, there's sort of like the Radcliffe Wave proper, it sounds like, and then there's something called the split that goes down into Scorpius. Can you tell us a little bit more about that?
Not that much. It was just mentioned in passing in the original paper, and I haven't seen a ton on it. So this is all the good stuff down in Scorpius and Centaurus. So we've talked about all kinds of dark and bright nebulae. If you look in the northern summer sky, and if you can go a little further south, you'll see lots of nebulae and dust clouds down there through that part of the sky. So it's not, as far as I know, physically connected to the Radcliffe Wave. It's a separate structure in its own right.
Okay.
And how it formed and how the Radcliffe Wave formed, nobody knows. Again, it might have been some extragalactic dust cloud that came and smacked into the Milky Way and caused some star formation. But it's a lot of material. So it's a lot of mass along the wave. I can't remember if I said how much in the article. I forget. But yeah, there's tons of stuff here. So this is one of the big puzzles that they're trying to sort out, not just how it moves along the Milky Way, both the Radcliffe Wave and the split, but how it formed. And are there other structures like this nearby? And with these big space telescopes and so forth, we can start to see structures like this in other nearby spiral galaxies too, especially face-on spirals. So there's a lot of work in this area.
Very neat.
I was kind of hoping maybe you'd say that you were going to do a summer article on the split that goes down into Scorpius.
Well, I might. I'm always looking for, for ideas for sure.
That would be a good one.
That same group with Catherine Zucker and Joao Alves, they've also published a lot of work on the local bubble. So we're kind of, as you may know, the sun is in this clear bubble about 400 or 500, 600 light years across that was likely blown out by a supernova, and the sun just happens to be passing through it, which is why we get a nice clear view. So on the surface of that bubble are the Taurus molecular cloud, for example, and other clouds. So yeah, there's all kinds of structures that they're sorting out and learning more about.
Cool. Nice one is the Eridanus arc, which I think is part of that bubble as well. Not sure if you've ever taken a stab at that one. You can need a filter for sure. Just it's sort of in Eridanus and then extends up into Taurus. I think it's I forget. It's like Vitor or something like that. But anyway.
Oh, okay. No, I don't know that one. I wonder if that's along the wave.
I don't know. Could be. I think it's part of the bubble. For some reason, I thought that was part of the bubble. But
okay.
I could be wrong. Yeah. Cool. All right. Do you have anything else for this episode, Shane?
No. Just thank you very much, Brian. It's always a pleasure to have these conversations with you. I really enjoyed the article and having the opportunity just to talk a little bit more about it. And, if anybody that's listening hasn't read the article, I echo what Chris said, that it's one of the better articles I've read in quite a while. So definitely check it out.
Oh.
Page 26, January 2023, Sky and Telescope. Yep.
Riding the Radcliffe Wave. Do you have anything that you wish to leave our listeners with before we sign off, Brian?
I think that's it. Enjoy these sights, but also keep in mind as you surf the sky that the connection between these things and the structure of the Milky Way itself, it makes this much more rewarding.
All right. Well, thank you so much for joining us today, Brian. I'm just going to scroll down to my outro notes. And thanks for everybody for listening. You can catch Brian's articles in Sky and Telescope magazine, where he is a contributing editor, and in Sky News magazine. Be sure to download one of his great Getting Started in Stargazing guides at cosmicpursuits.com. Thanks again for listening, everybody.
Thank you, everyone, for listening, and we hope you enjoyed the show. If you are interested in more information, would like to contact us, or if you would like to support the podcast, check out our website, actualastronomy.com.